So interesting enough, what happens when you graph this phase minus this phase, basically you're gonna get a sine wave. You're gonna get a perfect sine wave, but this orange sine wave represents the phase to phase. So B phase minus A phase, and if you were to draw the phase to phase voltage, this amplitude of this orange graph that we graph now is going to be at 1.73. okay, so if you were to do the calculation, that's why when you're working in your rubbers, for example, in the primary, if you touch phase to phase, you're going almost twice the voltage of your line, because it's 1.73 times the peak. So if you go face to ground, you'll be at 1, but if you go face to phase, you'll be at 1.73. So let's say you're dealing with 2400 face to ground voltage. You multiply that by 1.73, which is 4152. So 2400 is face to ground, and then face to phase voltage is 4 kV. That's, you know, some of the systems that we see out there. So keep that in mind. That's where you get the face to phase value. This factor is always 1.73. So whatever this value is here, face to ground, your face to phase voltage is going to be a factor. Factor means the multiplication time. It's going to be a factor of 1.73. That depends. This number here, 1.73, comes. It depends on your phase shift. This is 120 degrees phase shift, right? Because we have 3-phase power. If we have 4-phase power, then you get 360 divided by 4, and that gives you 90 degrees. So you'd have 4, instead of having A, B, C, you would have A, B, C, D, and instead of this being spread apart 120 degrees, if you have 4-phase power, it'd be spread apart 90 degrees, right? Because of this, you need equal balance. So if this phase shift gets smaller, your factor 1.73 would actually get smaller. I don't know what it is. I could find it out. But if the more phase, the more like 3-phase power, 4-phase. If you have like 12-phase power, this number would start approaching 1. This number gets smaller and smaller until it approaches 1. So if you had 1,000,000-phase power, for example, the phase-to-phase difference would be like 1. It would barely be any difference at all. But anyhow, that's where that 1.73 comes from.